Hello everyone and welcome to our today's class. It is our fourth and last lesson on the topic rectilinear propagation and reflection at plane surfaces. So let me start by giving you the quote of the day, which states that yesterday is gone, tomorrow is not guaranteed, you only have today. Make the most out of it. So today we'll be discussing about images formed by mirrors at an angle. That is when two or more mirrors are inclined at an angle. What will be the effect of how the images will actually be formed on such particular mirrors. So under this there is a formula that we usually use to calculate the mirrors at an angle, that is the images between mirrors at an angle, and this is the formula. Number of images formed, that is when mirrors are at an angle, is equals to 360 divided by the angle between the inclined mirrors, which is denoted by theta. Yeah, we call this one theta, then minus 1. So that is the formula that we usually use to find the images between mirrors which are inclined at an angle. So in short, n represents the number of images formed, is equals to 360 divided by theta. Theta represents the angle between the of inclination between the mirrors, then minus 1. So we look at an example here which states that calculate the number of images produced by two plane mirrors inclined at a 90 degrees. Calculate the number of images produced by two plane mirrors inclined at 90 degrees. So from our formula, n, which is the number of images formed, is equals to 360 divided by theta, which is the angle between the two plane mirrors, then minus 1. So here we simply substitute. So if we are told that the mirrors are inclined at an angle of 90 degrees, it means our theta in this case will be 90 degrees, because theta represents the angle of inclination between the two or more mirrors. So here we have our theta is 90 degrees, that is for case A. So if I do substitute here, so I have 360 divided by 90, that is n is equal to 360 divided by 90, then minus 1. So 360 divided by 90, actually 0 cancels with 0. 36 divided by 9, you get 4. So here we have n is equals to 4 minus 1. So 4 minus 1, so n is equals to 3. So remember, n represents the number of images formed. So it means that for two inclined mirrors at 90 degrees, the number of images produced will actually be 3 images. They will be 3 images. Then if two mirrors are inclined at an angle of 0, that means that the two mirrors are actually perpendicular. No, they are actually parallel to each other, because the angle between two parallel lines is simply 0 degrees. That's why we usually say that parallel lines may never meet. They may never meet. Why? Because they are parallel. That is, there is no, the angle between such two mirrors will actually be 0 degrees. So it means we'll say number of images is equals to 360 over theta. Theta is the angle between the two mirrors. So because for parallel mirrors the angle is 0, so it will be 360 divided by 0 minus 1. Now remember, whenever you divide a number divided by 0, that is a number greater than 0 divided by 0, the answer will always be infinite. The answer will always be infinite. So this will be infinite minus 1, you simply get infinite. You get infinite. So infinite means that the images formed are either they will be blurred, or there are severally many images such that they are overlapping, or simply there is no image formed. Now remember that the number of images formed by two plane mirrors placed at an angle to each other, it depends on the angle of inclination between the two mirrors. So the smaller the angle of inclination, the more the number of images. Then of course the larger the angle of inclination, the more the images. So the law of reflection also applies for mirrors at an angle. They also apply for mirrors at an angle. Then the number of images formed can be obtained by the formula that we have set up here. So it means if the angle of inclination between two mirrors is a large value, it means you are dividing 360 divided by a large number, therefore the quotient will be a small number. So the larger the angle of inclination, the lesser the images formed. For example, if the angle of inclination is large, like 360 degrees, it means for that case we will have 360 divided by 360, which is 1 minus 1. So 1 minus 1, you get 0. So it means no image will actually be formed. So the larger the angle of inclination, the smaller the number of images formed. But when the angle of inclination is small, for example, if the angle is 0, or even if it is 1, the images formed will be 360 divided by 1, which is 360 minus 1, you get 359, which are very many images. So the smaller the angle of inclination, the more the images formed. The larger the angle of inclination, the lesser the images are formed, because you are dividing with a larger number. So if the angle of inclination is 0, it means the two mirrors are actually parallel to each other. Therefore, the images obtained will be infinite. Infinite means very many images beyond our instruments. That is, the instruments we have or our naked eyes cannot count the number of images. So we say they are simply infinite. But if the angle of inclination is beyond 360 degrees, then in that case we don't expect any images to be formed. So maybe we cannot another example here involving inclination of plane mirrors. So an example reads that two plane mirrors are inclined at an angle of 60 degrees to each other, full stop. A ray of light makes an angle of 40 degrees with mirror M1 and goes on to strike mirror M2, full stop. Find the angle of reflection of the second mirror M2. Now remember, we said that the angle of reflection, this is simply the angle between the normal and the reflected line. So sorry, here the ray of light should be emanating from I forgot to indicate the direction, but it should be having the direction. So assume that the ray of light is moving from this direction downwards. It comes, hits the first mirror downwards, then it also hits the second mirror. So there should be arrows here indicating the direction. So there is an arrow here downwards, an arrow here downwards, then an arrow here upwards. So if the two plane mirrors are inclined at 60, that is the angle of inclination between the two mirrors is 60 degrees. So in an exam, please don't make an error of drawing rays without an arrow. A ray of light must have an arrow. It's only that I forgot to indicate them there, but they should actually be there. So we have a ray of light moving downward. So if the angle of inclination is 60 degrees, that is between these two mirrors this way. So mirror 1, then mirror 2, they are inclined at 60 degrees to each other. A ray of light strikes, makes an angle of 40 degrees with mirror 1. So if this is mirror 1, then this is my ray of light. It's making an angle of 40 degrees with the first mirror. So it means after it hits, it actually be reflected through the same angle. Remember, the angle of incidence will always be equal to the angle of reflection based on the law of the first law of reflection. So if this is 40 degrees, this must also be 40 degrees. To mean the angles of incidence, this one represents the normal. To mean the angles of incidence and reflection here will be 40 plus 40, you get 80. Then this angle from here up to here, this is a straight line. Angles on a straight line will always add up to 180 degrees. So 180 minus 80 degrees, you get 100. So means 100 divided by 2, this will be 50. This will also be 50. Then the same ray goes downwards to hit that particular angle, that particular mirror, that is mirror 2. So if this is 60, then this is 40 because it is the same as that. Then this is a triangle. Angle sum of a triangle will always add up to 180 degrees. So 60 plus 40, you get 100 180 minus 100, you get 80 degrees. That's why you are seeing me, I have my 180 degrees here, because these are angle sum of a triangle which add up to 180. So if this is 80 degrees, it means that the ray that will emerge, this one will also be 80 degrees. Now 80 degrees, then 80 degrees, those are angles on a straight line. So if angles are on a straight line, they add up to 180. So if this is 80, then this is also 80. 80 plus 80, you get 160. Then angles on a straight line add up to 180 degrees. So it means that we have 180 minus 160, you actually get 20. So it means the angle between these two rays here, although they should be having the arrows actually, is actually 20 degrees. So because the angle of incidence is equals to angle of reflection, it means we'll divide by 2. So 20 divided by 20, you get 10 degrees, then 10 degrees. So the question wanted us to find the angle of reflection of the second mirror M2. So the angle of reflection of the second mirror, this one, will be 10 degrees. Sorry for the error. There should be an arrow here pointing downwards, and also an arrow here downwards, then also an arrow here upwards, because rays of light must have arrows, otherwise we will give you a 0 in the exam. Now we look at, I give you an exercise here that you will actually try during your own free time. So question 1 reads, calculate the angle of inclination between two plane mirrors that will produce one image. So the expected answer is 180 degrees. Remember the formula used is just n is equals to 360 over theta minus 1. Only that in this case you are given the number of images, then you are required to find the angle. So you just make theta the subject of the formula. Then to produce no image, no image means the images is 0. So you substitute appropriately. The expected answer is 360 degrees. Then another question here reads that sketch the diagram. Sketch on the diagram the path of the ray until it leaves the two mirrors, indicating the angles at each reflection on the mirror 1 and mirror 2. Again here I forgot to indicate the arrow, but the ray is emanating from this direction, then coming downwards. So there should be an arrow here pointing downwards. Sorry for that error. So you indicate after the error has hit the first mirror, that is M2, how will it emerge to come and M2? So we need they need the angles of incident and reflection for mirror 1 and mirror 2. So the expected answers are, on the mirror 1, I expect the angle of reflection to be equal to the angle of incidence, which is 30 degrees, then mirror 2 the same 30 degrees. So try sketching that and see whether you get the same. So there is an arrow here pointing downwards. There is an arrow here showing that the ray is emanating from this direction and is incident on mirror M2 because before it is reflected. Then lastly we look at the applications of plane mirrors. That is, where do we apply plane mirrors in real life situations? So plane mirrors have a wide application, but there are two main applications of plane mirrors, and that is one in a kaleidoscope, then two we have in a periscope. Now how does a kaleidoscope work? So a kaleidoscope applies the principle of mirrors at an angle. So initially it was produced as a toy under the name mirrorscope. Initially it was called a mirrorscope. It consists of two mirrors, that is M1 and M2, placed or inclined at 60 degrees to each other inside the tube. Then the bottom of the tube is a ground glass plate for admitting the light. So on this plate, that is this is what we are calling the round tube. So the bottom of the tube is usually a round glass plate for admitting or to allow the rays to enter. So in this plate, on this plate is scattered small pieces of bright colored glass which act as objects. So this is just a symbol diagram showing how a kaleidoscope works. So basically it has two plane mirrors which are inclined at an angle of 60 degrees. So this represents the object Then these are the images. One image, we have another one here, two here, we have another one here, then another one here. So I12 simply means this is an image that is obtained by reflection from the first mirror followed by a reflection in the second mirror. This one is I212. That represents reflection starts from the second mirror, the first mirror, then the second mirror. So the most important thing is to know its application. That is where it is applied. So a kaleidoscope is used by designers to obtain ideas on systematic patterns. A kaleidoscope is used by designers to obtain ideas on systematic patterns. So its main application is used by designers, or it is used in designing. So it is inclined at 60. So if it is inclined at 60, it means the number of images formed will be, remember our formula was n is equals to 360 over theta minus 1. 360 divided by 60, because the angle of inclination is 60, you actually get 0 and 0 will cancel, so that 6 divided by 6 you get 6. So 6 minus 1 you get 5 images. That's why you are seeing we have 1, 2, 3, 4, 5 images. So the expected here is 5 images. So we are saying that the most important thing is to know that a kaleidoscope, in a kaleidoscope the mirrors, the plane mirrors are inclined at 60 degrees. Then a kaleidoscope is an instrument used by designers to obtain ideas on systematic patterns. So that is its application in designing. Then lastly we look at what we call a periscope. Now what is a periscope? So a periscope, this is an instrument used to view objects above obstacles. An instrument used to view objects above obstacles. It is used in submarines and also to watch over crowds. So that is its application. So you can be asked to state one application of a periscope in real life situation. So you say a periscope is used in submarines and also to watch over crowds. That is, if somebody is maybe deep in water, then he wants to see what is happening on the surface. Remember, a periscope usually has a very long tube. So the person is here deep within water, but the periscope is emerging on top of water, so he can actually see what is happening on the surface of the water while downwards. That way you are saying that a periscope is used in submarines and also to watch over crowds. Then the images seen with the aid of the instrument are erect and virtual. That is the nature of the images formed by a periscope. They are erect. Erect means upright, and they are also virtual. Virtual means they are imaginary, or they are not formed by actual intersection of the real rays of light, by the real rays. Then a simple periscope can be constructed by, that is as shown here, a simple periscope can be constructed by arranging two plane mirrors inclined at 45 degrees to the horizontal. That is as shown in this particular diagram. Then the rays from the object are reflected by the top mirrors and then reflected again by the bottom mirrors into the observer's eyes. That is, we have an object here. This is our object here. Then rays of light. Remember, the rays of light will always emanate or originate from the object, because it is the object that reflects the rate of light to the eyes of the observer. So the rays of light are originating from the object. They come here, they are reflected by the first mirror, which is inclined at 45 degrees to the horizontal. The rays are reflected downwards, then again reflected to the eyes of the person. So this is where the image will appear to be. So the image is dotted because it is virtual. Then a more elaborate periscope are used in submarines. Here prisms are used instead of mirrors, and the tube supporting them incorporates a telescope to extend the range of vision. So a telescope can be used to add on the periscope so that they can see objects that are very far away from the observer. So here is a demonstration of how a periscope can be used to see above obstacles or even crowds of people. So we have an object here, then it will actually be seen from, remember the observer is downward here, then this is an obstacle, so the person cannot see what is happening on this other side. But with a periscope, because it has a very long tube, actually the person is able to see what is happening here, because the rays are reflected then downwards up to the eyes of that particular observer. So if you are asked to give two applications of plane mirrors, you simply say they are applied in a kaleidoscope and in a periscope. Remember we said in a kaleidoscope the mirrors are inclined at 60 degrees. Then kaleidoscope, its application is that it is used by designers to obtain ideas on systematic patterns. It is used in by designers, or it is used in designing. Then a periscope, the mirrors are inclined at 45 degrees to the horizontal. Then it is used in submarines and also to watch over crowds. So we've come to the end of our class today, which also marks the end of the topic, this actually particular topic, which is rectilinear propagation and reflection at plane surfaces. But we need to discuss the quote of the day. So the quote of the day stated that yesterday is gone, tomorrow is not guaranteed. You only have today. Make the most out of it. Yeah. So the quote simply warns us of procrastinating. Remember, it is always said that procrastination is the greatest thief of time. Yeah. If you have to do something today, please don't carry it to tomorrow. Do it today, tomorrow find something else to do. So avoid procrastination. So yesterday is gone, tomorrow is not guaranteed. You only have today. Make the most out of it. Again, also in life, you need to enjoy life to some little bit. Don't just aspire for greater things tomorrow. There is no guarantee that tomorrow you will be alive. So appreciate the present moment. Appreciate the present moment. And there is also, I'll add you another quote, which says that aspire to be inspired before you expire. I said aspire to be inspired before you expire. And also remember this: as long as you are still breathing, it means there is something more you can do. Many wish to have that breath that you just took now, but they are not alive. So life is precious. So actually take it with the seriousness that it deserves. This is Kind Tuition Academy. Kindly hit that subscription button on YouTube. Thank you.